Okay, we've got a question about a problem where a projectile shot up into the air, stops after a certain amount of time, after a certain amount of distance and whatever. So just looking, and we're assuming, I think, a linear drag force.
Right.
So, means our net force is equal to, if we choose upward as a positive direction, negative mg because of gravity. And, oh, I did a dumb thing. And, fix it in a minute. And negative gamma v for the drag force. Okay, so we do this and then we divide through, in other words, F net becomes mx double prime. We divide both sides by m, except I didn't divide this by m, so that m should never be in there. Right? Okay, so I fixed that, mostly. Okay? And we get this, rearrange it to this form, non-homogeneous, first order linear equation. And don't know why I wrote it twice, but I did. Oh, no, yeah, I did. Okay, so I wrote it, obviously why I wrote it twice, but, okay, there's our first order linear, but we don't have an x term in it. We just have an x prime and an x double prime, which is just a variable and its derivative, if we let x prime be the variable. Of course, that's v, so we change everything over to v. So now we got v prime, x double prime is v prime, x prime is v. And there we have a very simple first order linear equation, which we'll just go ahead and solve as separable because it's really easy to integrate. Okay? But we could do, first order linear integrating factor and all that stuff. We come up with the same thing. And you should be used to that. Okay, so solving this separable and skipping, the gory little details. This is going to go over here, and then we're going to get, well, it reduces down to dv over gamma over mv plus g equals negative dt, and that's very straightforward. I put the negative sign over here, so I didn't have to deal with it over here. Then integrating this is very simple. We could do a u substitution. We would find that du equals gamma over m dv, so that dv is m over gamma du. So we'd have an m over gamma from that, and we get this. Now it's simpler because the way I see it, and it's totally equivalent because it's just a chain rule thing no matter how you do it when you come right down to it. I know it's going to have this because it's linear in v. Okay? And I know that the derivative of this has to equal this. So I got to have an m over gamma out here because the chain rule is going to give me a gamma over m here. Whichever way you see it, it's a simple integral and it's pretty standard stuff by now. Okay? So we get absolute value of gamma over mv plus g equals ae to the negative gamma over mt. The negative gamma over m comes from multiplying by gamma over m on both sides. E to the any constant is just a positive constant. So our solution, the absolute value of this equals some positive constant times e to the negative gamma over t. We can take care of the absolute value by just saying that gamma over m v plus g equals ae to the negative gamma over m t. I got negative sign big enough, right? But since we remove the absolute value sign, we can now say that, that a is any constant other than 0. Of course, if a is 0, it's not an interesting solution anyway. Okay? So there we have it, so that v equals mg over gamma, which is going to be your terminal velocity, okay, plus ae to the negative gamma over mt, a being an arbitrary constant, just absorbs the m over gamma that we multiplied by, right? So now we have our velocity as a function of time, and now we can stop and think about just what our conditions and the problem are, because you're claiming that there isn't enough information. I think there is, but I haven't looked that closely at the problem, and since I wrote it, it's possible there isn't. Okay, so let's see what's going on.